Hi everyone and welcome to this episode of Keipert Labs. Today's video is all about the concept of ionisation energy, or IE for short. So I'm going to start by refreshing your memory of the Bohr model, and then I'm going to use some of my little magnetic buttons to illustrate some of the key concepts around ionisation energy. Okay, so just as a quick kind of recap of where we're up to in our understanding of the atom, we're thinking about the Bohr model, which was developed around about 1913. Okay, so it's been around for just over 100 years. And so two of the kind of key concepts that we're going to be building or kind of working with here is that the atom consists of a positively charged nucleus around which orbit electrons which exist in energy shells. Okay, so electrons being negatively charged, as Thomson identified, and that they orbit around the nucleus, and that rather than orbiting just higgledy-piggledy, that they are located, or kind of we can visualize or model them being in these different kind of layers called energy shells. Okay, so I'm going to clear this off, and I'm going to use my little colored buttons to set up a model of the atom for you to draw. Okay, so what I've set up here is a really simple model of a hydrogen atom. Okay, so based on how Bohr understood it. So we have a positively charged nucleus in the center, and then we have a single electron orbiting around that nucleus at some distance. Okay, now at this stage Bohr hadn't been able to identify what was inside the nucleus yet, thinking about protons and neutrons. Those concepts were still a few years away, so we're not going to worry about them just at this particular second to explain what we need to see anyway. Okay, so the hydrogen has this one electron that orbits around the outside. And so one of the properties that we can measure about atoms is how easily this electron can be stripped away from that hydrogen atom to leave it as a positive ion. Okay, and so this measure we call ionisation energy. Okay, so here's the definition that we're working with. So it's the energy required to remove an electron from an atom. Now, you would remember from the past that we can make positive and negative ions by losing or gaining electrons, but specifically this amount of energy is only in relation to taking or removing an electron from an atom, okay, rather than how much energy would be involved in putting another one in, because that's not easily quantified. Okay, so for hydrogen, we're looking at the amount of energy that it takes to remove one electron. Okay, so we would consider, we can classify ionisation energies by, how many, so for which electron we're trying to remove, the first one, the second, the third one, and so on. Okay, because then if we say go to helium, helium has 2 electrons. Okay, and so we're only able to remove one at a time. We remove them in successive stages. Okay, so we talk about successive ionisation energies. Okay, so looking at this now, so that I would have the energy involved in removing the first one would be my first ionisation energy, and the energy to remove my second one is my second ionisation energy. Okay, and so then let's say I'm going to go to lithium. Actually, I'll write this down a little bit lower, as you'll see in a second, because lithium, what we've identified, and you may well remember from earlier kind of study, is that actually lithium has an arrangement of electrons like this, that we actually consider 2 different shells, that there's 2 electrons in the first one and then 1 in this third shell. Second shell. The third electron is in this second kind of dotted layer. Okay, so our first ionisation energy is stripping this one away, and then our second ionisation energy and third ionisation energy. Okay, so we can measure how much energy is involved at each stage to remove that, and the more energy that is required, that is to say more energy is harder. Okay, now that does say more, not move. Okay, so more energy equals harder to remove. Okay, so that's an important idea. So that an electron that is easier to remove will require less energy to make it happen than something that is harder to remove. Okay, and so what we're going to do in the next activity, we're going to look at looking at these energy values and see what it tells us about the structure of an atom. All right, thanks very much for watching. Bye for now.